Hello, good morning again. Uh, we just looked at the overview of what is sampling and sample size and the reason behind choosing huge sample size or more sample size. Then we looked at the three principles of sampling. So by now, I really hope that you must have got some concept of what sampling is all about and what are the reasons why we have to take more sample. Let us now look at what are the sampling strategies and uh, quantitative and qualitative research. To begin with now, as we saw, the marked difference between quantitative and qualitative research in terms of sampling is that in quantitative research, the sample size is predetermined, meaning you have got a fixed sample size in your mind. However, in qualitative research, you do not have predetermined sample size in your mind, but you collect the data from the respondents or you collect from the data from your study area until you reach data saturation, meaning until you feel that you're not getting any new information or you're getting new information, but the new information is negligible. So that's the marked difference between qualitative and quantitative research. And again, we have different sampling designs or strategies, you can say, for qualitative and quantitative research. So most of the qualitative and quantitative sampling strategies go hand in hand, and you just have to know that whenever you are using the different kinds of sampling designs, the only difference between qualitative and quantitative when to use is between the predetermined sample size and the data saturation point. So let us look at those sampling designs, but let us look more towards quantitative research because we are not dealing much with the qualitative research, because one way or other way, whatever sampling design that we are applying to quantitative goes to qualitative as well. So in quantitative research, we have got sampling design, three kinds of sampling design. One is random, one is non-random, and the other one is mixed sampling. So in random, we have the first one, simple random, where we basically pick the samples randomly. Then we have got stratified random, which is again divided into proportionate and disproportionate. I'll again talk more on that one in later slides. Then we have got clustered sampling. Again, I'll be talking on in later slides what are different kinds of cluster sampling, what is actually cluster sampling, how they are different from stratified sampling. I'll be talking on different kinds of cluster sampling in a while. Then we have got non-random or probability, non-probability sampling. We have got sampling strategies like judgmental or purposive. Then we have got quota. Then we have got accidental. We have got snowball sampling. Then we have got expert sampling. And with mixed sampling, we have got systematic sampling. So one of the classes we dealt that systematic sampling can be brought under random sampling, but here we are taking out from non-random and random, and I've got reasons for that one. Mainly from this layout, I just want to convey that this is not very rigid, this is not very confined sampling designs. There will be many other sampling designs, but overall these are the commonly used sampling designs or commonly used sampling methods. And again, you can base your sampling methods on these sampling designs. Let us jump to these sampling designs one by one. Firstly, we'll look at random, or we'll look at probability sampling. Then we'll be looking at non-random, and then we'll be looking at mixed. If you just go to what is random sampling, to call as a random design or random sampling design or probability sampling design, there are two criteria to fulfill. One is the criteria of equality, the other one is the criteria of independent. Meaning, whenever you are choosing sample, those samples should have equal probability of getting selected. For example, the population size is 10 animals, or 10 crops, or 10 forest trees, or let's say 10 respondents to the total population, and the sample size, let's say, is 3, either like 3 respondents, or either like 3 trees, or 3 crops, or anything else, but 3 out of 10. And if you're choosing 1 out of 3, then the probability of getting selected of that one sample, of that one respondent, is 1 by 10. So it has got every chance to be get selected from the 10 respondents, or 10 total population. So equal chance, that means it's not being affected by any other physical or any other factors. So it has got equal chance of getting selected. The second one is the selection of one element is not dependent on the choice of another element. That means, for example, again, let's base on the 10 respondents in total. From the 10 respondents in total, if your number of samples is 3, then let's say that you directly went to that place or that class, let's say the class. So let's take an example of forestry third year. So I'm the researcher, and I want to research on a certain topic, and my number of sample is 3 from the 10 class strength. So I go to the class, and suddenly I choose randomly one person, and that one person, though it has got equal probability of getting selected, but it happens that the next person that I'm choosing is not very willing to participate in my research. Maybe because that person is not being totally being influenced by the first person, or the second person that I have to choose is totally being forced, or is totally being recommended by the first person. Let's say I have to choose 3 person, and I've chosen the first person. Let's say I have chosen Sagar as one of my respondents, and now my next person has to be randomly chosen. Let's say I've chosen Namka right now, but before choosing Namka, it tends to happen to me that Sagar really wants his closest friend to be chosen as the next respondent. So he's actually influencing me to choose another respondent. So that independent is not there. So it's quite dependent, because the second sample is dependent. So instead of choosing Namka by myself, Sagar really wants me to choose Sumit, because Sumit is very close to him, and like that. And when I choose Sumit, now from Sumit really wants me to choose the third respondent. Let's say Sonam String. So Sagar influences Sumit to be chosen. Sumit influences Sonam String to be chosen, and that's dependent on each other. But in reality, if you want to call it as random sampling, it has to be totally independent of each other. So I can choose Sagar, I can choose Namka, I can choose Jimshurin. So that's how the random sampling should be. It has to have equal chances, and secondly, the choice of respondents, or the choice of the element or the unit or an animal or crop or tree, anything else, should not be deciding the next choice, or it should not have been decided by the earlier choice. So it should be totally independent. There are mainly 2 advantages of random sampling. One is that since we have randomly chosen the samples, the results that we get from the random samples is quite something that we can generalize to the sampling population. So I just randomly picked 3 of them, and the views from 3 of them, because I've chosen randomly, I did not oversee anything else. So the views of these three students can generalize the whole classroom. Second is that the statistical tests, whatever test that we are using, whatever statistical test that you are learning, most of the tests are based on p-value. If you just remember, that's probability value. And probability value, the significance p-values and all, can be applied only if your samples have been chosen based on the principle of probability. That means the principle of random sampling. And those kind of tests can be applied only and only if you have chosen the samples with random principles, equal and independent. So these are the two advantages that random samplings have. So I said there are three kinds of random samplings now famously used: simple, stratified, and clustered. So let's discuss on the three. So before deciding with discussing with the three, I would like to say how to exactly choose these three kinds of sampling. For example, you have got 30 numbers of, or like, let's get back to the 10 total population and three respondents or three elements that we need to choose from the total. How am I going to choose this three? And this three can be chosen through some activities like fishbowl. This happens if the number of if the total population is countable, is very few, and you can manage it. So you write everything else, every name of your sampling frame, the list of this 10 respondents or 10 plants or trees, anything else, write it down here and just choose randomly the three from these 10 written papers. So this is what fishbowl draw is all about. Second one is these days you can use computer programs like Excel, equal to rand, open the bracket and just type anything else. Random numbers can be generated. First three, just sort the random numbers properly, and the first three random numbers can be chosen, and you can choose those first three corresponding random numbers and choose those respondents as your samples. Or if you're looking at study area and if you're laying out your plots, sample plots, which we'll be discussing again in next video presentation, how to lay out transects, how to lay out quadroids, point samples and all. So if, for example, if you want to lay out your point samples or like quadroids in different parts of the study area, you can lay out these days with computer programs like GIS. So QGIS, ArcGIS provides one of the best platform to lay out samples randomly or with non-random approaches like systematic sampling. So computer programs are always there. Third one is famously being used, and it's still famously being used by many researchers, is a table of randomly generated numbers. So if you look at most of the research methodology books, if you look at most of the statistical guidebooks or statistical books, at the end you'll be seeing a table of randomly generated numbers. That means these are the numbers that's being randomly generated for us to select our samples randomly. Let's say that let's just give ourselves an example. Let's say that from the total population of 968 students in CNR, let's say that sample size that you need to take to study some specific title is around 250. And to choose the 250, if you are told to use a table of randomly generated numbers, then what you can do is just choose randomly the number, the column. For example, I've chosen column 4. Then if I've chosen the column 4, just you can choose randomly, or you can systematically choose this column. It's okay on you. Then if I've chosen the column number 4, then I'll be choosing the three last digits. So my sample size is 300, or like I said, my sample size is 250. So 689. So it's not qualifying. So this is not my sample. Then before that, it's important for you to give the student ID or some kind of like identity to those respondents or those samples, so that when you're choosing randomly, you know whether these individuals have got into the samples or not. Let's say that I've given the ID to all the students. Let's say we are following, or let's say that we are following the student ID, the last digits of our student ID, and let's say that the student IDs are all arranged based on the uh, based on the numberings, well formatted numbers. For example, the first student that got registered is around like 0 CNR 00001. Second student is like CNR 0002. Third student is like 0003, and like 100th student is 00100, and like 250 student is 250th student is 00250. So let's select that, and let us now choose this 250 individuals randomly. So 689 doesn't qualify to be under 250. So then we have got 752. Then we have got 393 not qualifying, but 171 can be qualified. So that's one. Then we have 203 is the next one. Then we have got 215 is the other one that qualifies. Then we have 013 is the other one that's qualifying. So here again it's qualifying. So we're just going to do randomly. We're just going to use the random digits from the table of random generated numbers. You could have also used the first three digits or the last three digits. It's on you again. How would you like to choose the numbers? So when you're done with the first column, if nothing comes, you can directly go to the next column, number 5, or you can directly jump to the column 8. It's on you again, because wherever you jump, the numbers that are being generated are actually random. I really hope you got something else from here. The basic thing that you need to know is that if you want to choose if you want to choose from let's say from 968 total strengths in CNR, if you want to choose 250 students, the first 250 those students who are having the first 250 numbers can be chosen based on these random assignments. The way that you're using the table of randomly generated numbers, again, depends on the digits and the column that you're choosing. So if you're getting confused on the use of randomly generated numbers, you can let me know. But as long as you know how to use computer program to generate these numbers randomly, that should be fine. So this is the generation of random samples, or generation of random numbers from the Excel. Let's see that we have got a total number of respondents 10, and our sample size is 3, just for example. And one of the methods to generate a random sample is through computer program, like I said. So if you want to use Excel to generate random numbers, what you can do is equal to RAND. This is the formula, and bracket open, bracket close, equal to RAND, bracket open, bracket close again. So a random number like 0.4 edit has been generated, and I'm gonna go like this, just write it down. So any random numbers are being generated. So I'm gonna copy it, and I'll just paste it over here, but paste just the values so that I do not change. And I'll delete this one. I'll just keep this one because these values will not change now. So these are randomly generated numbers. So let us just keep our cursor like this, and I'll just go to sort and ascending order. So do you want to expand? Yes, I want to expand. So the first top three, list top three, or you can take it from the bottom or the top, it's on you. So if I take from bottom, if I take from the top, top three samples that I need to take is the person with 5th identity, 9th identity, and 7th. So this is how random numbers are being generated from the computer program. So again, before going on with the types of random designs, let us look at again two technical terms. One is sampling without replacement, and one is sampling with replacement. For example, it's very important for us to know whether we are doing sampling without replacement, or are we doing sampling with replacement. For example, if you have 10 populations over here, if you're taking 5 as one of your sample, and if you have just taken 5, then the probability of choosing 5 from 10 is 1 by 10. Now if you are taking next as 7, or if you're taking next sample as number 7, so the probability of getting number 7, if you're not taking back number 5 to the total population, then the probability of choosing number 7 is 1 by 9. Only if you're not taking the number 5 back to the total respondents. What I'm telling you is that once if you have taken number 5 out as one of your sample, if you're not replacing back number 5 when you're choosing the second sample, like sample number 7, the probability of selecting sample number 7 from already taken out one sample, that's 5, is actually 1 by 9. For 5 we have probability of 1 by 10, because there were 10 samples and we took out 5 out of 10, so the probability is 10. But if you're not again putting back when you're choosing the next sample, the number of sample number 7, if you're not counting the 5 again, then we are taking only we are taking out one sample out of 9 total populations. If you want to take out now number 2 here, and if you're not replacing now 7 and 5, the probability of taking out number 2 is 1 by 8. So what I really mean by here is that I'm not replacing my sample that I have taken out. So that's what is meant by sampling without replacement. So sampling without replacement is again against the random principle, where we need to have every sample to have equal chance of getting selected, or equal chance of probability. What we saw just here is that to get 5 to be selected as the sample, it's having a probability of 1 by 10. But if we have to select number 7, we are getting the probability of 1 by 9 if you do not replace 5 back. So this means that the probability of getting number 7 selected and the probability of getting number 5 selected are different. So it's not equal. So it rejects the principle of random selection. But instead, the sampling with replacement is just opposite. If you have taken out number 5 here as one of our first sample, then if you have to take out number 7 as a second sample, we need to take back the number 5 into the total respondents, and so that even number 7 should have the probability of getting selected 1 by 10. So again, if during the second selection, instead of getting other numbers, but we are getting the same number repeated. For example, if you are taking the second, if you have taken 5 as the first sample, and again if you are taking out the second sample, but again 5 is coming back, then what we can do is we can always throw the 5 back to the total respondents, and we can again try picking up the next respondent, just to keep the equal probability principle alive or valid in the random principle. So I really hope that you got sampling without replacement is that you're not putting back, or you're not counting back the sample that you have just selected. Instead, you are just leaving that sample out from the total population. But in case of sampling with replacement, whatever sample that you have taken out is again being counted for another sampling. So if you feel that that same sample has come out during the second stage, you can always choose another sample until you reach your sample size. So that's the difference. And only that sampling with replacement fulfills the criteria of equal probability, which is one of the main criteria of random or probability sampling design. So please choose sampling with replacement if you want to fulfill your principle of random sampling. The first random sampling is called as simple random sampling. This is just choosing through any technique, like if you have got 10 respondents in total, if you want to choose 3, then you can choose through any methods like feasible method, a computer program method, or table of randomly generated numbers. But please take care of 2 things here. Those samples that you have chosen has to have equal chance of getting selected, and it should have the independence of the sample that you have already been chosen, or the sample that you are going to choose. So for example, I've laid out if I've laid out different sample plots here, and these all the numbers of these plots or area are kept in the fishbowl or kept in the Excel file format, and I just want to choose 3, or like I just want to choose like 4 or 5. Let's say I want to choose 5, and I can always get this random numbers. Then I see that my 5 samples are being chosen. So that's how simple random sampling is being chosen. So this is one of the most widely and commonly used simple random sampling technique around the world for any kind of research. The second one is if the population is homogeneous, if the study area is homogeneous, then that's totally okay if you have to use simple random sampling. Just lay out your plots, or just go to that area and just randomly pick someone else. But what happens if your study area or the population is having a very diverse group of community, diverse group of characteristics, diverse group of types? Like if you are going to a forest, you see that study area is having 5 different kinds of forest, and simple random sampling. If you just throw simple random sampling, and if you see that most of your plots are going to only 2 types of forest, then it will be totally biased for you to take the data for all the 5 forest types. And that again happens with animals and animal dwelling area habitats. That again similarly happens with the crop patterns and all. So to address this kind of heterogeneity or the variation, what we can always do is we can divide those heterogeneous population into small stratum, meaning those stratum should have common characteristics. So if you go to a study area and that steady area is widely being divided into disturbed and undisturbed, widely being divided into disturbed and undisturbed. But if you're taking simple random sampling directly on these two areas, there may be chances that only one plot will fall in disturbed and most of the plots will be falling in undisturbed. So if you remember principle number 3 here, principle number 3 says that the more diverse, the more heterogeneous the population is, the more sampling error or the biasness arise from our research. So to minimize this heterogeneity, we can always use some kind of like strata to make the sampling error less, so that this heterogeneity can be addressed. So the basic thing is that we want to decrease or we want to reduce the diversity or variation in the population. So if you're going to a community where you want to look at perspective of environmental science or perspective of agriculture from different people, so the perspective of the younger generations will be totally different than perspective of mid-level who are productive, who are really working hard to get the agriculture system in the country. Those people who have really worked hard, again the older or the senior citizens. So there are, let's say, there are three kinds of people here, and if your sampling is mostly falling in the young generation, the kind of data that you'll be getting is totally like biased, because most of them are not really acquainted with the agriculture system. It's the mid-aged people and the senior citizens. So what happens here is that even if you are trying to do sampling on the mid-aged people who are productive, who can really contribute to agriculture, you're again exaggerating your data. And if you are talking about the older people, again your data will be different. So what we can always do is that we can stratify based on their age. We can stratify younger, mid, and older citizens or senior citizens, and we can always take number of request samples from younger, mid, and senior citizens, and we can get different views. So these groupings are known as stratum. This can be also done based on the gender. For example, if you want to see some views on some kind of like gender related issues, if you are doing your sampling mostly on males, then the results will be completely different. If you're doing more on female, then the results will be again completely different. What we can always do is make them into two strata, male and female, and whatever data that you get from female and whatever data that you can get from male can be mixed, and you can look through these data differently. Forest type we just talked about. So these are different kinds of subgroups, or these are different kinds of strata. In research, if you feel that there are different heterogeneous or like variation in your study area, it's always wise for you to make those into strata and then collect number of samples that you require. For example, if you require 30 sample plots from 5 different kinds of forests, if you have in that study area, then you can always divide 6 sample plots in this 5. So 6 5 to 30. That's what is called as proportionate random sampling. You want to look at number of plots that you need, and the study area, and you are taking exactly the equal proportion that you need to take from those study area. That's proportionate sampling. Again, if you look at the number that's being distributed in those, if they have got different ranges, let's say you have got 3 strata, high stratum, mid stratum, and low stratum. If you have to look through a proportionate stratified sampling, then in the total population, low is 700, mid is 200, and the high is 100. If you look at the proportion, is 7:2:1, and the sampling that you need to do, for example, if you have to do 100 number of sample from those people or that area, then 70, 200 to 20, and 100 to 10. So it becomes, so this is the kind of like proportion that you're taking from the study area, the distribution of the respondents, or distribution of your sampling units in that stratum. So if looking at the proportion, you can also take. But if you're not looking at the proportion, even if it is like 700 or 200 or 100, but if you just need 100 from 1000, if you just randomly take 34, 33, 33, that becomes again 100. You're not looking at the proportion of the distribution of individual in that group or in that stratum. You're just randomly picking up your sample size, your sampling units. That's disproportionate sampling. Again, that's on you, whether you're taking a disproportionate or proportionate. Wherever proportionate is possible, take proportionate. Wherever proportionate is not possible, take disproportionate. Proportionate in real natural science field can be, for example, again, let's get back to 5 different kinds of forest types. If these forest types are almost equal in size, let's say one is like 0.8 hectare, one is like 1.2 hectare, one is like 1 hectare, and one is around like 0.7. These are more or less equal in size, because in a natural setting you will not have 1 hectare broadleaf, 1 hectare conifer, 1 hectare chirpan forest, 1 hectare mixed forest and all. So it's just up and down, and if you see that the area is quite similar, then you can always go for proportionate. So if you have to lay out 30 sample plots, and if you feel that this proportionate is, this sample area is proportionate, then just take 6, 6, 6, 6, 6 each from this 5 different kinds of forest types. But if you feel that first forest type is around 5 hectare, second forest type is around like 1 hectare, third forest type is around like 10 hectare, and the fifth forest type is around like 20 hectare, then again there it's not fair enough for you to take 6 sample plots from all of them. Just look at the proportion that they are contributing to the total study area and take the proportionate sampling. So again, that depends on you, and whatever sampling strategy that you're taking on a stratified, which is again one of the most commonly used, remember to reflect whether it is proportionate or disproportionate sampling. Again, this is very useful in looking at the population which is usually having high variation or having heterogeneity. But what happens if the population is very large? Even if it is heterogeneous, but it's very large. For example, you have to look at whole Bhutan, or let us say you have to look at whole Southeast Asia, or like Asia as a continent. In that kind of large populated area, or the large city area, what you can always do is that you can always leave stratified sampling and go for elder brother of stratified sampling, that's cluster sampling. So cluster sampling basically looks at making clusters of large area into little smaller of that large. And again, the second or the double step looks at again going deeper of that cluster and finding out a narrower cluster or a small cluster, and again going more steps to find out your particular specific area. I'll just give an example. You want to see the environmental knowledge of students in various Dzongkhaks in Bhutan. Students environmental knowledge in different zongoks in Bhutan. What you can do is, firstly, you can make a cluster. Like first cluster can be a Eastern student. I put Eastern because I'm from East, so it's always first. Just kidding. One is Eastern cluster, one is Western cluster, one is Northern, and one is Southern cluster. And we have got four cluster at first stage. Second stage, that four clusters from Eastern side, you're not going to choose all the Eastern because it's very large. So let's just choose one, Trashikang. So I've just chosen Trashikang in second step. In again second step of another like Northern, I'm choosing basically some kind of like Lindsay as one of my cluster. And from West, I'm choosing Thimphu, and from South, I'm choosing Chirang, let's say. Second step. Third step, I'm going to choose from Trashikang. I want to choose a school called as let's say Jimmy Sherabling Higher Secondary School. Okay, from there, that's the third step. And from Northern, I'm going to choose from Lindsay, I'm going to choose Autsu Middle Secondary School. Then from Thimphu, I'm going to choose RTC. Then from Chirang, I'm going to choose Damphu Middle Secondary School, or Damphu Higher Secondary School. That's my third level cluster. Fourth level cluster, I do not want to go and select all the students of Kaling Jimmy Sherabling Middle Secondary School, all the students of Autsu Middle Secondary School and all. But I want to choose specifically class 12 science of Jimmy Sherabling Higher Secondary School. Then class 10A of Autsu. Then BSc Environmental Science of RTC. And let's say class 9 of Damphu Middle Secondary School. So that's the cluster. And from there now I'll start taking up my data. And whatever data that I'll be getting will be the summary of how students feel about the environmental perspective. So that's how cluster works. You're basically working in the large area. And let's say I'm going to study pygmy hawk in south and central Bhutan, another example. So I choose one. These are the first cluster, southern central Bhutan. And the second cluster can be, one of the second cluster method can be, I am choosing Dagana. So to Dagana, I have lots of forest type which where pygmy hawk may be found or not. I do not know. I don't have much idea on pygmy hawk, but let's say that maybe we can find in one of the forest types. So I choose not all the forest types, but one area where it's likely to have forest types. So go there, just choose randomly in that area. And similarly for Trongsa, you can choose Sabrang, you can choose Shimon, you can choose a forest type, and Samti you can choose a forest type. And the last, I can make my cluster sampling from there. So very important thing to know about cluster is that it can be applied mainly in large population or large area. And if you're using just a single stage cluster sampling, then first step itself you are getting the cluster that you want to take samples from. Double step, after second step you're getting the cluster that you want to sample. The multiple step or multiple stage cluster is something that you want to reach to that particular cluster after n numbers of steps. So thank you so much. We are done with random sampling. Let us now look at non-random sampling in the next video presentation.